Let's take a look at an application problem that involves finding slope. Missy is driving from New Orleans, Louisiana to Dallas, Texas. At 2 p.m., she is 140 miles from New Orleans. At 5 p.m., she is 350 miles from New Orleans. We're to graph the line that represents the distance from New Orleans at a given time, and then find and interpret the slope of that line. I have a graph already done for you, and notice what I've done. The horizontal axis is in time per hour. Notice it goes from 0 to 6 hours. And the vertical axis is in distance, representing the distance in miles. Now let's go back to our problem. She's driving from New Orleans, Missy is, and she's traveling she's going to Dallas. At 2 p.m., she is 140 miles from New Orleans. So I'm going to start at 0, and I'm going to go to 2, which represents 2 p.m. She is how much? 140 miles. So I'm going to put a dot here, a point here, that represents the coordinate 2 p.m., 140 miles. And then at 5 p.m., she is 350 miles. 350 miles from New Orleans. So I'm going to put point here and write that as 350. I'm going to graph this line. And then find the slope. We'll recall the slope formula. y2 minus y1 over x2 minus x1. Okay? Well, let's call this x2, y2. Sorry, x2, y2. And we're going to substitute. This is 350 minus, let's call this x1, y1. 140 over 5 minus 2. And when we subtract, we get 210 miles divided by 3. And what's that equal to? 70. So our slope is 70. Now what does that mean? That means that Missy is traveling at average speed of 70 miles per hour.